So today on the bench we have a Lafayette LM-300. This is I don't want to say it's unique because there are some other radios that do the same thing. Whistler had, and I think I've even done a video on the Whistler, but it has two channel selectors, two displays, two channel selector knobs. It has two PLLs, two VCO mixer circuits. Now, the idea behind this is a primitive, is probably the best way to say it. It's a primitive way of scanning. Now, it only scans two channels. That's what the two channel selector knobs are for, obviously. It's not like a modern radio where you can program in memory channels. Now, there actually were some radios that were out in this time frame that actually had memory channels. But they were, I mean, don't get me wrong, this was an expensive radio in the day. Actually, all radios were expensive back then, but this one was at a premium. But, oh, what is that? The Keycom, I can't remember the number off the top of my head. It's an SBE Keycom. It actually had programmable memory channels. Did not have channel knob. It had a keypad. But, yeah, this, like I say, this was a cheaper way of doing scanning with two channels. Now you could actually do the scan, set the scan up in two different modes. The way I have it set up right now, because I currently have it set up to channel 19, radio's upside down, but that's 19, and then the other channel is channel 6. And actually, if you heard that little weep, the kind of tone, that's the other way you can set this radio up. There's another switch over here and it has a little IND, and if you put it down in the IND, if the secondary channel breaks squelch, it will actually give you a tone. So you can hear that every time it's sensing that there's a signal that is enough to break squelch, it'll give you an alert tone. And then there's a squelch and then a scan sensitivity. So what you do is basically, then depending on what mode you're using, turn the radio on, set your channels, because the squelch control actually works for both controls. That's why it has a separate scan sensitivity. That's basically setting the sensitivity of the second PLL circuit, second receiver circuit. Actually, it's the same receiver, because like I say, it has two channel selectors, two PLLs, two VCO mixer circuits. It shares receivers, but when this PLL is turned on, when this part of the radio is turned on, the scan sensitivity then sets it at a different level. That way, you know, if you have different signal levels on these two channels, it allows an independent control of each of those. Basically, you can think of that almost as like a RF gain control for the second channel. But I'd done a video showing this radio. I got, I don't even remember, was it 6, 7, 8 radios that day? All mine. This is my radio. I just stuck 3 of them up on the bench, kind of some horrible-looking radios, some kind of oddball, unique radios, this being the one, because, like I say, not a lot of radios you see with two channel displays. The other one was a Tram D62, and then the other one was a sideband RCA Copilot. I basically, you know, unboxed them, sat them on the bench, hadn't even opened them up yet. Started the camera, if you've watched that video, you know, and I just went through and tried all 3 of them, and none of them worked. Which is, you know, bad for me. Yeah, they're my radios, means I gotta fix them. But good for you guys, so, you know, because that's kind of what I wanted to see, especially the 2 that kind of looked horrible, the Tram and the RCA Copilot, the sideband one. That'll give me some repair videos to actually show how to go through diagnostics and what I find wrong with them. But as I always say, the absolute first place to start any repairs on anything vintage electronics, I don't care what it is, CB radio, television, amateur radio, I mean, it really does not matter. The first place to start, replace the electrolytic capacitors. So many times, over the years, because I used to do, I'd troubleshoot a problem. And I'd find, oh, bad electrolytic capacitor. I'd replace it. Oh, radio's got another problem. I'd, you know, spend a half hour troubleshooting. Oh, another bad electrolytic capacitor. Replace it. You know, you'd find like 3 or 4 problems. Good Lord, now you've got an hour or 2 hours wrapped up in diagnostics time. You're going to replace the electrolytic capacitors. You are going to replace the electrolytic capacitors, right? in my case, because this is my radio, I know I'm going to change the electrolytic capacitors on it. I do the same thing to my radios that I do to customers' radios. I recommend them to customers, but for me, that's a given. If it's mine and it's old, I'm going to change the caps. And that's all this needed. It had CCS, crappy cap syndrome. So at least 2 of these caps are bad. Because I actually did just, and not a lot of diagnostics. I mean, literally, I spent like 30 seconds. I just flipped the radio over, hooked up a scope probe to the PLLs, and both PLL VCO circuits were dead. Changed the caps, turned the radio on, the radio works fine now. So obviously there was at least one electrolytic capacitor bad in each of the PLL VCO synthesizer circuits in this radio. So this is one of those radios that just proves my point. You'll save more time, because in my case, I know I'm going to change all of these. If I had wasted my time troubleshooting it to find it's a bad cap, then troubleshoot the other PLL VCO mixer circuit just to find, another bad cap. I just went ahead, replaced them now, then I test the radio. If the radio works great, hey, thumbs up, I just saved myself a bunch of time. If not, there's no loss, because I'm going to change these anyhow. These things are 30 plus years old. So, they've well outlived their life expectancy. So, that's pretty much all to this video. Actually, just in case you didn't see that other video, and you don't have to go watch that one, I'll just show the inside of this one. So this is a Cybernet radio. Pretty much anything made by Lafayette, if it's a solid-state radio, you're going to find a Cybernet chassis in them. Most radio manufacturers, not all, there are a few exceptions to the rule, they might have used both of them, but most manufacturers used either Uniden or Cybernet. There are some of the other radios out there. You may find Hitachi and a few other oddball companies that actually made the boards, not the radio itself, the whole radio, but the board manufacturers. But for the most part, most radios in this vintage are going to be probably Cybernet or Uniden chassis. So this one actually has, like I say, 2, and they're not just a normal channel selector switch. You can see they're a kind of an oddball, really big, heavy die-cast front end on this thing. They really sit back off of the face of the radio. So yeah, I'm sure those cost a pretty penny. Has 2 PLL-02As. Actually, let me just unplug it. Get all of these wires and microphone unhooked from it. Be a little easier to move this thing around. If I'll ever get the light right where you can see it or not. Oh, for Pete's sakes. And I don't have my little flashlight in my pocket, do I? Okay. Forgot to stick that in my shirt pocket today. We'll get out another one. Oh, don't tell me this one's got dead batteries in it. Got to be kidding me. Really? Okay. Hang with me just a second. Let me just reach over here, grab another 3 batteries, slap him in his flashlight. There we go. Get the God light turned on. That's the only thing I hate about this. It's too bright. But you can see there's a PLL-02A right there. And if we spin the radio around, you still can't see it for the wiring harness. There's another, man, this light's too bright. Right down there by my thumb, you can see there's another PLL-02A. So like I say, it has 2 complete circuits. And one nice thing about radios like this, back in the day, when you used to buy a radio, really, if your radio ever broke and you took it to a shop to get repaired, they didn't need a service manual if you took the literature that came with your radio. And this radio is no exception, and I wish manufacturers did this today. This radio came with, in the box, this was standard practice back in the day. It might not have been a big fold-out like this, and this is on nice heavy cardstock, but a full-size schematic. But you can see 2 channel selectors, 2 displays, 2 PLL-02As, 2 VCO mixers, and then basically they come out through their buffers and then they are both connected here, and then the rest of the radio is pretty much like any other radio with the exception of the scan circuit. But as far as the receiver transmitter circuitry, that's all pretty much the same as any other radio is going to be. The main unique things are it's doubled here and has the scan circuitry. But yeah, like I say, they came with a nice schematic. So this is the owner's manual. This isn't a service manual. But you head to the back of it and get out of the instruction section. And here's the alignment procedure in the owner's manual. Block diagrams, how all the circuits work, truth table for the PLL chips, everything you'd need to know basically, to service the radio in the owner's manual. Why can't we do that nowadays? I'm not talking to most people watching this video, but if there's any radio manufacturers watching, why can't we do this? I'd pay an extra couple dollars for a radio if you would just include this with the blasted radios. We all know it's electronics. It's going to break one day eventually. But, yep, so there you can see. The only thing I really have to do to this now is I have not done an alignment to it, so I need to do an alignment. Honestly, I'll probably never use this thing. It'll get set up on a shelf. Because this one's actually in better condition. I have at least one. I think I have two of these, but I know they're not in this nice a condition. Like I say, this one's in the box with even with the original factory correct microphone. I've got lots of Lafayette radios, but I think this is the only one I know of that took this microphone. It had this aluminum trim that went around the side of it, so it's nice that it came in the box with all the accessories because they have the proper microphone for it. But I'm trying to see actually it's right there. So that guarantees it's a Cybernet. It's got a board number that starts with PTBM. Anytime you see something like PTBM as a board number, that's a Cybernet chassis. The wires here, those are factory. They're not bodged on afterwards. You can see they just go down to the indicator lights. So yeah, this was a completely untouched radio inside. All it needed was electrolytic capacitors. So, yep, if you have an old radio and you feel confident, now I'm not saying on this one because this one's a little bit challenging to do the caps on, but if you get a radio like this, especially if it looks like it's in almost brand new condition and you don't see where it doesn't look like anybody has ever been inside the radio, but something just doesn't work or at all, and you feel confident changing the electrolytic caps, give it a whirl. Get on, especially if you have, schematic and parts list and whatnot, just make out a list of which electrolytic capacitors you need. Go to whoever your favorite electronics supply company is, like DigiKey, Newark, Allied. I mean, there's Mauser. There's all kinds of companies that sell electronics components. Get good quality ones. You don't need crazy expensive ones. Don't waste your money on audiophile caps. But, Nichicon, Panasonic, Matsushitas. I mean, I don't have enough fingers on my hands to count all the quality cap manufacturers nowadays. And if you buy from a supplier like DigiKey or Mauser, companies like that do not sell cheap caps. They don't sell the junk Chinese caps. So even the cheapest capacitors they sell are still going to be good high quality caps. But, so there you go. There's maybe I can convince a few of you to tackle working on your own radios. What are you going to do? Break it? It already doesn't work. And if it still doesn't work afterwards, you can then send a radio to somebody like me or somebody else or your local repair shop and then get it diagnosed and repaired. But you can save yourself some money by doing all of this work yourself, And in a radio like this, it's actually all but four capacitors. All but four capacitors are very easy to change in this radio. They're all mounted down on the main board. Easy to get out. The four challenging ones are your meter board. So this is your SWR bridge and has some of the other meter circuitry on it. Has one electrolytic capacitor on it right there. And so you have to put, and you can't, of course, solid metal chassis in the back, so you can't get into it. So you have to desolder it here, desolder it where it's soldered down to the main board, pull this board, and you can't get it out very far, but you can get it up far enough to desolder it. And then there's 3 other electrolytic capacitors dead underneath this board here that the channel selectors. So they're crammed way down in there. Actually, that's not that bad. In this radio, it was just a matter of desolder this one wire so I could pull the front face out a little bit farther. Pull 2 screws here, 2 screws here. That allowed me to pull out and fold the faceplate away. That's why I had to desolder this one white wire so it wasn't tight as a banjo string. But then with the faceplate folded around, I could desolder the 3 capacitors that are right in this area here and get them changed. But, you know, you do something like that, you can save yourself a considerable amount of money. Because that's, you know, the parts don't really cost that much. It's the labor is what kills you when you're, especially if you're restoring an old radio. That can be a sizable amount of your bill doing stuff like changing the caps. So, you know, if you do that, then the only thing your local repair tech or whoever you send it to has to do is diagnose actual problems. Hopefully, you install your caps correctly. Or your bill might actually be more expensive than if they changed it. But, yeah, so please make sure you stick the caps in the proper polarity. Get your positives and negatives lined up properly. But, like I say, you can save yourself a considerable chunk of money, and shoot, if you're a collector, you do that to a couple radios, you might be able to save yourself enough money by doing cap jobs yourself that you can buy more radios. You know, if you save $100, let's say, per radio, you know, depending on what it is, 90-ish to 150, I mean, depending, every radio costs a different amount of money to recap. You know, they have different amounts in them. Takes, like this one has some of them are difficult to get to, where in most radios they're not. They don't have ones that are, you know, hard to get to. But I mean, it can be from a couple dollars in little tiny small modern style radios that may only have 6 or 10 electrolytic capacitors in them, to a radio like this, to a radio that can have 2 to 3 times as many as this in it. But, yeah, save yourself a lot of money. Shoot, you can buy a couple extra radios. So, there you go. I just thought I'd show this one. It is up and working now. So, the Lafayette LM-300. All it had was a bad case of CCS.